Do another problem here.
Do these word problems actually want you to like switch a positive into a negative because of the situation that it's giving you?
Yeah, so you have to, if something is increasing, it's positive, it's decreasing, it's negative.
Okay.
So let's do numbers, what did we do right now? Number 16? That's number 16, okay. Let's do number, number 18, I'm not a big fan of these problems, but you got to know how to do it. So let's do 18. Do ones with the similar triangles. All right, so let me draw the picture here first. So that's a light, by the way, the red dot. Okay, a spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second, how fast is the length of the shadow to the building decreasing when he's 4 meters from the building? So here's what's happening. You got a guy that's 2 meters tall. So that blue line, that's the guy, and he's 2 meters tall. And I'm just going to go ahead and put a 2 there, not a variable. Here's why. Remember, these related rates problems, you're reading, you're like watching a short video. Throughout this short video, let's call it a 10-second video, this guy will remain 2 meters tall. His height is not changing. Now, the shadow on the wall, the height of that is changing. So the height of the shadow, we'll call that y. That's this distance from here to here. We'll call that y. But that y is changing because as this guy gets closer and closer to the wall, so his shadow right now is this tall. So let me, so right now where he's standing, his shadow would be right here against the wall. See that little gray thing that I drew? Now, as he's walking, as he's getting closer and closer to the wall, let's say that the guy is now, hypothetically speaking, is right here. So same distance too, but now the light would hit here, so the shadow would be only this tall. You see what I mean? So as he gets closer and closer to the wall, the height of the shadow decreases because, you know, because of the angle. Does that make sense? Okay, so the question is, when he's, let's go back to the problem. When he's going at a speed of 1.6 meters per second. So let's go ahead and call this distance from here to here x. That's how far he is from the spotlight. So we're going to call dx over dt 1.6 meters per second. So he's going fast, 1.6 meters per second. So he's just walking casually. Now, why am I calling this positive 1.6 meters per second? Because notice he's going towards the wall. So if he's going towards the wall, he's increasing x. So it's going to be positive. Now, the spotlight is 12 units away from the ground, from the walls, right? So the spotlight is 12 meters away. So this distance from here to here is exactly 12. So what would this distance be then from where the guy is to the wall?
6.
6? Where'd you get 6 from?
I don't know.
12 minus x?
Yes, 12 minus x. Yeah, because, yeah, exactly. Because if this is x and this whole thing is 12, it would be 12 minus x. Now, I'll tell you the trick on these problems. These problems, these always these spotlight problems where the guy is going away from the light or towards the light and there's a shadow. These types of problems, when you run into them, you're going to use similar triangles. But what I mean by similar triangles is there's two triangles here, and these are all right angles. So you'll see the small triangle right here that I'm pointing to. And there's this large triangle that I'm pointing to. And they're similar. They have the same three angles. They're similar by angle, angle, angle. So what happens is, if two triangles are similar, then you can set up an equation by one, let's say as saying, hey, y is to 12 as 2 is to x, right? Because if they're similar triangles, if y is to 12 as 2 is to x. So let me repeat that. So here's y, this side, is to 12 as 2 is to x. So they got to have similar ratios. Now, I'm going to cross multiply and say, let me go with black. So if I cross multiply, I get xy equals 2 times 12, which is 24. Divide both sides by x, y equals 24 over x, which is the same thing as y being equal to 24x to the minus 1. So my question is, the question that they're asking is, when he's 4 meters away from the wall or the building, how fast is this shadow changing? Well, we better get a negative number, right? Because the shadow is decreasing. We already established that. So we're going to take the derivative of both sides with respect to t. Rewrite it. Oh, I forgot to take the, hold on, I messed this up. I forgot to, when I took the derivative. When I take the derivative with respect to t, derivative of x is dx over dt there, right? So negative 24 over x squared times dx over dt. Now I can plug in what I know. So I'm given what dx over dt is, which is this guy right here. Well, what is x? Well, remember, the question says, how fast is the shadow changing when he's 4 meters from the wall? If he's 4 meters from the wall, meaning that red line segment is 4. So what should x be then? When he is 4 meters from the wall, then x equals
8.
8, yes. Because if that's 4, 12 minus 4 is that's x is 8, because they got to add up to 12, right? All right, so we know everything that we got to plug in now. 24 over 8 squared times dx dt, which is 1.6. So you go ahead and put that in your calculator, and we get negative 0.6 meters per second. Why negative? Because the shadow is decreasing. So dy over dt is negative 0.6. Now, that's a tough one. I'll tell you, when I was learning this stuff and I'm taking calculus, similar triangle ones were not that pleasant to me. I got the Pythagorean theorem once, but the similar triangles ones kind of confused me sometimes. Now, I know this section is kind of tough and some of this stuff is going over your head, but I got good news for you. This next one, I think you'll get.
Sorry, Professor, can you explain how you got x equals 8 again? Sorry.
Because the distance from where the spotlight is to the building is 12, right? So if he's 4 meters from the building, what's x?
Okay, all right.
12 minus 4, which is 8.
Yeah, all right, thank you.
All right, you're gonna like this next one. It's I think a little bit more basic, and it's gonna be the Pythagorean theorem. You guys understand the Pythagorean theorem, right? A squared plus B squared equals C squared. Okay, so I think you'll like this one. Keep in mind, when you do the homework for this section, there will be problems that you know how to do. You might not know how to do one or two of them, but some of them will not even be a word problem. The equation is provided for you. So like question number 1, it says, if V is the volume of the cube with edge length X and the cube expands, well, if it's a cube, meaning all the spaces are the same, so it's like a six-sided dice. Well, if one side is X, well, the width, length, height, they're all X's. So just fill it out as you can. All right. This is going to be number 20. Let's just go here, new page. Now, for those of you who do not play baseball or have never watched baseball, I don't blame you. They call it a baseball diamond. I'll tell you exactly. It's basically a square that lands all the time. Oh, hold on. Give me a second here. Yeah. Why am I not going straight? All right. Yeah, I guess messing this up. I gotta try to work. That's good enough. That's supposed to be a square. Now, it's a baseball diamond is basically a square, but it's like on it's right angle like that. But these are still right angles. Okay, so for the rules of baseball, this is called home plate. This is first base. This is second base. This is third base. So the object of baseball is you hit the ball from home plate, then you run this way towards first, and you run towards second, and then you run third, and you towards home. Okay. So that's how baseball is, as far as you know baseball for now. Now, let me read the problem. A baseball diamond is a square with a side of 90 feet. So that saying is from here to here, that whole distance is 90 feet. From here to here, that whole distance is 90 feet, and so on going around. It's a square, so they're all 90 feet. A batter hits the ball and runs towards first base, basically at 24 feet per second. So, batter hits the ball from home plate, goes this way at a speed of 24 feet per second. So what all you do is... What happened? Well.
I think I but I didn't mean to. I just hit my space about that.
So if the batter hits the ball and goes at a rate of 24 feet per second, so the distance he goes from home to, let's say he's right here, that distance we'll call X. Since he's increasing X, because he's going from one plate towards first, so he's going up that way. So we're going to say dx over dt is 24 feet per second. I think that's pretty fast, runner, but I'm not sure. So what would this distance be from where he's at to here?
Should it be negative 24 because the distance is getting smaller?
No, X is getting larger. X. He's going home first. It wasn't that red line segment getting larger?
Oh, okay. Yeah.
So the question is, so I have to read the question. Part A, we're only going to do part A here. At what rate is this distance from second base increasing when he's half first base? So again, you're watching a several second video here. The guy hits the ball, he's running home plate first base. That's the video that you're watching. Now watch. As he's running towards first base here. Isn't his distance to second base getting smaller and smaller and smaller because he is getting closer to second base as running towards first. He's not running direct to second base, but he's indirectly kind of getting closer and closer to second base as he's running this way. You guys buy that?
Yes.
So the question is, when he's exactly halfway to first base, wait, is this changing to second base? So we're saying this distance right here. So when he's half first base, that's what he has the red dot. What is the distance to second base changing? So what we'll do is we got this distance right here, this blue line segment. What am I going to call this blue line segment?
90 minus x?
Yes, 90 minus x. Correct. What am I going to call this orange line segment? It's a trick question. You're probably going to say why, but no, we're going to call it 90. And I'll tell you why. I'm not even going to give it a variable. Because throughout this 10-second video that you're watching, this whole time, that distance from first to second will remain 90. It's never going to change. So we can just call it 90 throughout the whole problem. Whereas this x changes. Depending on where the guy is, the shape of this triangle, this blue triangle changes. If he's here, so depending on where you pause the video, this changes, but this orange line segment does not change. So we could just call it 90. Now, what is this? That's his distance to second base, which we'll call S. Or you can call it H for hypotenuse. It doesn't really matter what letter you assign. I'll call it H. It doesn't matter because this is a right angle now. So we got to form a triangle. So I got 90 minus x squared plus 90 squared equals h squared. I want to know, essentially, they're asking us find dh over dt. How fast is it changing from how fast is this? Is the second changing? So basically, they're asking us what find dh over dt. Now we got our Pythagorean theorem right here. So 90 minus x squared, that's the blue, plus the 90 squared, that's the orange, equals h squared, which is the hypotenuse of the triangle. Now let's take the derivative of everything with respect to t. Be careful here. It's 2 times 90 minus x times the derivative of the inside. What's the derivative of 90 minus x? Negative dx over dt, because it's a minus x. Derivative of 90 squared, that's 0. So we don't even rewrite that, equals 2h times dh dt. So find dh dt when x equals 45. Why x equals 45? Because they said when the runner is halfway to first base. So that means x equals 45. I still need to know what h is, though. If x equals 45, so when x equals 45, you got 45 squared plus 90 squared equals h squared. So I'm trying to figure out what h is at that time. So I'm going to do this side problem here. So I get 10,125 equals h squared. So h equals the square root of 10,125. So going back to this problem, since h equals 10,125, I'm going to plug it in for h there. So 2 times 90 minus 45 times negative dx dt, which is negative 24. We got 2 times 45 times negative 24 equals, we already did that. Let me just, so 2 times 45 times negative 24, which is negative 2160, equals 2 times the square root of 10,125 times dH dt. You get that? And you don't need to rationalize the denominator. Just put this in your calculator to give you a decimal approximation. And as long as the answer in the back of the book, if you put that in your calculator, it gets you the same approximation, it means you did it correctly. So we got a negative answer because, well, the distance to second base is getting shorter and shorter and shorter, so it's got to be negative. The rate which h is changing is getting smaller, right? Because h is this distance. So what's happening here is, let me wait until you finish writing this down, then I'll explain more. So what's happening here is, I'll scroll back up here for a second for you to look at it. So you got your baseball diamond, and this dude is running this way, right? Okay, so at first his distance to second base is all of that. But as he's getting closer and closer to first base, you see how his distance, that line segment is getting smaller and smaller and smaller, right? At first, it's this orange line. Oof, let me draw a better picture. So at first it's that black line. Then it becomes like that. So as you can see, as he's running this way, first his distance is the black line, which is a pretty long distance. Then it's blue, then it's green, then it's red, and and then it gets this distance, and it eventually becomes 90 feet. But what we're saying, when he's exactly halfway to first base, so that's essentially like where the green line is at right now. At that particular moment, how fast is h is decreasing? And we came up with the rate of negative, it's decreasing at 10.73 feet per second. Because you can see that line segment is getting smaller and smaller and smaller as he's running towards first base. Essentially, that's what's happening. Does that make sense? No? Oops. We have a negative, the rate of change, h is negative because h is getting smaller. dH over dt means how fast is h getting smaller and smaller and smaller? It's getting smaller and smaller and smaller over this 10-second video that you're watching, so it's negative. If you're getting further and further away from second base, then it's going to be positive. James, does that make sense or no?
Oh, I was asking if it was like negative 10.73 feet per second.
Yeah, that's it. It is.
Okay.
Yeah, it is. Then write the feet per second. Is that what you meant?
Yeah.
Okay, so this last problem only, number 20, the one that I just did. On a scale of 1 to 5, 5 you completely get it, 1 you're completely lost. Can you give me a number here on the chat? All right. I know. I realized I didn't explain it too well. I don't know why. I didn't get a good feeling this day. I did a much better job last week, but I think that was my morning class. Today's a different book. Anyway, do the best you can on the homework. Again, keep in mind, not all of them are word problems. Some of them are just you're given an equation. We'll go more over this again, don't expect to know how to do every single problem just by looking at it right away, but you do what you can, and then eventually I'll post the answers to the word problems for you. You got the math lab that can help you. You got Aaliyah as well. And then, of course, we'll talk about it. As far as the quiz this Thursday, it's not going to have any word problems. It's going to be 3-5 and 3-6. So 3-5, 3-6 is the quiz this Thursday, which is implicit differentiation and the log section that we just covered. And yeah, and then we'll just we'll talk some more. So and then on Thursday we'll talk about some of this, and then we'll do three. We still got to do 3-10 and 3-11. All right. So have a good couple days, and I'll see you Thursday.
Oh, sorry, Professor. I forgot to ask. What was on the quiz again?
3-5, 3-6. I wrote it down right here.
Okay. Sorry about that. Thank you.
Yes, sir.